Okay, so question number 8. What is the complete electron configuration of aluminum? So to find the electron configuration of a certain element, we need to follow the following steps. So step 1 is to divide your periodic table into your orbital sections. Which is either the S, P, D, or F orbitals. So I'll Google it, show what it'll look like. Find a better. Oh wait, that was the same one. Okay, so this is a better quality. So for example, the S block is in light blue, which is our first two columns. The P block is shown in green, and the D block is this orange. So it's the middle transition metals. And then finally, the last two rows is the F block, which is all the lactanides and actinides. So the second step is to start from hydrogen. You kind of move left to right across the periodic table. Writing the row number, then the block letter. And once we get to our D block, instead of writing the row number, we write the row number -1. And for the F block, it's going to be the row number -2. And we also need to write in order of increasing energy levels. Okay, so now let's try to answer our question, finding the electron configuration of aluminum. So this is ground state aluminum, which means that there were no electrons that were removed or added. So first, let's find aluminum on the periodic table. You'll see that it has an atomic number of 13, which means it contains 13 protons. And since we have a neutral atom, this also means there are 13 electrons. So we can double check if our answer is correct if we sum up all of the superscripts to find out the number of electrons. So first, let's start from hydrogen, and we write the row number, which is 1, and then the block letter, which is S. And then to signify how many electrons are in this orbital, we write the superscript of 2. So 1s2 corresponds to the hydrogen and the helium. Then we go down to the next row, which is row 2. Block letter is 2. And having a superscript of 2 adds another 2 electrons. And then we move across to P. 2p6, and then the next row is 3s2, and then we go 3p and then count to see where aluminum is. So aluminum is right there, so we just need to say 3p1. And now we have the electron configuration for aluminum. And we can also express this in the shorthand configuration. And to do that, we just need to find the noble gas that comes before aluminum, which in this case is neon. So we write neon in square brackets. And then we just continue on writing the rest of the electron configuration normally. So 3s2 and then 3p1. Okay, so let's see what the junior tutor said. A noble gas configuration of an atom consists of the elemental symbol of the last noble gas prior to that atom, followed by the configuration of the remaining electrons. Elements that are found in the last column of the periodic table are an important group of elements called the noble gases. For example, sodium, element number 11, is the first element in the first period of the periodic table, which has the electron configuration 1s2, 2s2, 2p6, 3s1, wherein the first 10 electrons of sodium atom are the inner shell, and the configuration of those 10 electrons is exactly the same as the configuration of neon. So this provides basis for shorthand notation. Okay, and then for aluminum, it has an atomic number of 13 and a complete electron configuration of 1s2, 2s2, 2p6, 3s2, 3p1. Hence, using the noble gas configuration principle, the electron configuration above is shortened to neon 3s2 to 3p1. Okay, so this solution is correct.